Welcome to Ducati Service. This video cassette and others that will be produced and distributed by Ducati Technical Service supplement the standard Ducati technical literature and training. The purpose of these video cassettes is to illustrate some of the most significant maintenance and diagnostic procedures for Ducati engines. This particular video cassette will guide you through some key procedures to ensure correct operation and top performance of the engine, namely disassembly, reassembly of the connecting rods, crankshaft shimming, gear selector drum and gearbox shafts shimming, gear selector adjustment. The procedures described here apply to all Ducati engines. The engine shown here is a 998R engine. The engine is shown removed from the frame, and the video cassette illustrates the total disassembly procedure up to separation of the two casings. This symbol identifies reassembly procedures or significant information concerning the component shown. Enjoy your view. Separating the casings of the 998R engine. Use the special stand, part number 88-713-1832, to facilitate engine overhaul. Disconnect the connector of the coolant return tube from the vertical head. Unscrew the retaining screw and disconnect the four-way connector from the horizontal head. Leave the O-rings in place in the engine. Remove the tube complete with connectors from the engine. Unscrew the 5 retaining screws of the coolant pump cover. The screw sitting at the opposite end of the pump inlet connector is fitted with a sealing washer, which must be renewed after each removal. Be sure to install this washer. Failure to do so would lead to loss of coolant. The coolant pump cover is retained by the sealant applied on assembly. Tap the cover at various positions around its contour until it comes off the generator cover. Slacken the clamps fitted to the coolant delivery tube to the vertical cylinder and remove the tube from the engine. Repeat for the coolant delivery tube to the horizontal cylinder. Separate the coolant expansion reservoir from the intake manifold of the horizontal head. Remove the reservoir together with its support. Begin removal of the side covers fitted to timing system side. Unscrew the 5 screws on the side covers of the head assemblies and the 3 screws on the center cover. Unscrew the nut on the mobile tensioner roller of the horizontal belt. Remove the washer, the eccentric and the mobile tensioner roller to release the belt. Remove the spacer bush and the horizontal cylinder belt. Repeat the procedure to remove the vertical cylinder belt. Unscrew the special screws on the connectors of the oil feed pipe to the heads and collect the copper gaskets. Always renew the copper gaskets on refitting. To disconnect the oil feed pipe, unscrew the special screw on the clutch cover. Leave the pipe on the engine. Remove the fixed tensioner rollers from the heads by unscrewing the retaining screw. Mobile and fixed tensioner rollers are identical and might be easily mixed up on refitting. Use the special key number 88-713-1821 to unscrew and remove the tensioner roller bolts. On refitting, apply medium strength thread locker to the threads and tighten to 26 Newton meters. Slacken the head nuts using the special tool number 88-713-2096. Remove the nuts and leave the special washers fitted to the stud bolts. Lift the complete head until clear of the stud bolts and collect the special washers. Remove the O-rings from the cylinder. Always fit new O-rings on assembly. Repeat the procedure to remove the other head. Unscrew the 4 retaining screws of the clutch inspection cover. Remove the cover with its seal. Unscrew the retaining screws and remove the spring caps and clutch springs from the pressure plate. Remove the pressure plate. Make sure to refit the pressure plate in the correct position relative to the drum on assembly. Remove the set of clutch plates from the drum. On refitting, position the set of clutch plates number 190 to 0111A as shown in the cross-section view and thus composed: A. Spring plate 2 pieces, B. Drive plate 8 pieces, C. 1.5 mm driven plate 2 pieces, D. 2 mm driven plate 6 pieces. Fit the locking tool number 88-713-2133 to the clutch housing and secure it to a firm surface. Slacken the nut using a 32 mm socket and remove the nut. Remove the retainers. Refit in the order shown in the figure. Remove the complete clutch drum. The drum used on this model has a metal insert that reduces wear dramatically. The clutch drum accommodates the cush drive rubbers. Push on the end of the inner hub to dislodge the rubbers when they need replacing. Lock out clutch housing rotation with the tool number 88-713-2133 you used previously and unscrew the 8 retaining screws. On refitting, apply medium strength thread locker to the screws. This will ensure correct tightening of the screws and proper sealing. Remove the tool and the clutch housing. Withdraw the clutch push rod and the bush with the O-rings. These O-rings must be renewed at each overhaul. slacken and remove all retaining screws of the clutch cover. Tap the cover at various positions until it comes off the engine casing and then remove the cover. Collect the O-ring fitted to the casing oil channel. Remove the clutch gear and the spacer. To avoid damage to the seal when refitting the cover, fit the nylon bush part number 88-700-5665 to the clutch gear hub. Unscrew the 3 screws securing the oil pump to the casing. Remove the complete oil pump and collect the 2 O-rings. Always renew these O-rings on refitting. Straighten the bent end of the washer to release the crankshaft nut. Mount the locking tool number 88-713-2102 to the holes of the primary drive gear and secure the tool to a firm surface. Use the bush supplied with the tool to slacken and remove the nut. Remove tool, safety washer, primary drive gear and inner spacer. Remove the spacer with O-ring from the secondary shaft. Remove the small cover mounted to the generator cover at the crankshaft position. Unscrew the 13 retaining screws of the generator cover. Install the puller number 88-713-1749 at the crankshaft position. Rotate the tool arm slowly until the cover comes off the casing. Insert the ends of the locking tool number 88-713-2036 into the 2 blind holes of the flywheel and secure the tool to the casing using the mounting holes for the side stand support. Unscrew the retaining nut of the generator flywheel using a deep 30 mm bush. Remove the Belleville washer and remove the tool from the engine. This is a self-locking nut and the face that contacts the Belleville washer is slightly tapered. Remove the generator flywheel together with the starter clutch from the crankshaft. Separate the starter clutch from the flywheel. On refitting, make sure to line up the flywheel reference mark with the notch in the crankshaft. Remove bush, roller bearing and shim as a set. The starter clutch used on this engine has a larger diameter to accommodate a larger roller bearing and inner bush for improved fit. Remove the timing gear from the crankshaft. Line up the timing marks on the timing gears on refitting. Lever out the crankshaft key with a drift. Straighten the bent end of the washer to release the timing lay shaft nut. Fit the tool number 88-713-1805 to the outer drive belt roller and secure it to a firm surface to lock out rotation of the timing lay shaft. Slacken the nut using a 22mm socket. Remove the nut, washer and idle gear from the timing lay shaft. Unscrew the retaining screw of the starter motor on the clutch side casing. Unscrew the 2 inner screws and the outer screw securing the starter motor to the chain side casing. Remove the starter motor and its seal. Unscrew the 2 retaining screws and remove the complete gear selector lever. Set the horizontal cylinder piston close to top dead center and raise the cylinder just enough to release the oil feed pipe to the heads. Lift the cylinder clear of the crankcase until you see the piston pin. Block off the crankcase opening to prevent dirt or other objects from falling into the crankcase. Fit the tip of a small screwdriver into the piston groove and prise out the retaining ring. Remove the piston pin retaining ring. Push the piston pin out of the piston to release the connecting rod. Remove the cylinder and piston assembly from the engine. Repeat the process to remove the vertical cylinder and piston assembly. Proper sealing between cylinder and head is ensured by a nitrogen-filled Wills ring, which must be renewed on refitting. To take the ring out of its seat, prick it with a sharp point punch. Use great care to avoid damage to the cylinder. Prise the ring out of its seat using the same punch. Remove the O-rings from the stud bolts to facilitate removal of the cylinder foot gasket. Remove the gaskets of both cylinders. Unscrew the screw of the gear stopper and remove the seal and the spring. Use a magnetic rod to collect the ball from inside the casing seat. Rotate the casing on the stand to give access to the lower mesh filter. Unscrew the 4 screws and remove the outer cover with its seal. Extract the mesh filter using a pair of tweezers. Pull hard enough to overcome the resistance offered by the inner O-rings. Begin to separate the casings, unscrewing the 8 outer M6 screws. Unscrew the 4 M8 screws placed near the horizontal cylinder opening and at the rear end of the casings. Unscrew the 2 M6 screws placed near the starter idle gear, using the holes in the gear. Unscrew the drilled M8 screw, which is identified by the red head. Caution: this screw must be discarded after it has been tightened twice. Turn the casing over and unscrew the 2 M8 screws on the clutch side. Turn the casing over on the stand so as to set the chain side up. Unscrew the two knobs and remove the bracket of the stand. Refit the generator cover to the casing, ensuring a correct coolant pump shaft, timing lay shaft fit. Secure the cover to the casing, fitting 3 screws at the opposite ends of the cover. Install the puller number 88-713-1749 to the crankshaft. Rotate the puller arm slowly until separating the two casings. Remove the chain side casing together with the generator cover. Lever under the second speed gear on the gearbox primary shaft with 2 flat blade screwdrivers to lift the inner ring of the bearing fitted to the shaft end. Remove the inner ring from the primary shaft and fit it into the bearing. Remove the crankshaft with connecting rods and shims from the casing. Remove the selector fork shafts. Push the forks aside and remove the gearbox drum. Collect the shim and fit it to the drum. Remove the forks from the gearbox shafts. Remove both gearbox shafts together. Collect the shim and fit it to the primary shaft. Connecting rods. The disassembly procedure is shown on a crankshaft fitted with Pankel connecting rods, i.e. the type used on the 998R engine shown previously, as well as on a crankshaft fitted with the steel connecting rods used on most Ducati engines. Disassembling the Pankel titanium connecting rods. Place the crankshaft in a vise and insert the piston pin to keep the connecting rods aligned. Insert the 2.35mm fork spacer number 88-713-1309 between the connecting rods. Insert the fork thickness gauge number 88-765-1000 or 1005 or 1006, i.e. whichever is the adequate size to take up play. Slacken the connecting rod bolts using a 10mm socket with an extension. Remove the tools and then the bolts. Withdraw the piston pin and separate the caps from the connecting rods. Remove the bearing from the connecting rod. Remove the bearing from the connecting rod cap. Crankshaft inspection and connecting rod bearing selection. Check the crank pins and the crankshaft main journals. With the crankshaft removed and the connecting rods disassembled, it is possible to clean the crankshaft inner oilways. Unscrew the upper caps. Unscrew the aluminium cap on the axis of the crank pin. Unscrew the drilled cap on the generator side journal. Clean the crankshaft oilways using wire brushes of adequate diameter. Renew the aluminium cap and refit the caps after applying high-strength thread locker to the threads. Screw the aluminium cap fully home and then cork it. Tighten all M8 caps to 13 Newton meters. Check the connecting rod class marked on the side of the connecting rod cap. Check the crank pin class marked on the side of the crank web at the factory. If the crank pin class mark has been deleted, measure the crank pin in various directions to determine its tolerance class. Connecting rod bearings are grouped into two tolerance classes that are color-coded red and blue. The table indicates the correct connecting rod bearing class to match crankshaft and connecting rod class. Fit the bearing to the connecting rod with the small tab matching the recess. The ends of the bearings must be flush with the contact face of the connecting rod. Repeat the procedure to fit the bearing to the connecting rod cap. Lubricate the connecting rod bearings with engine oil. Fill the crankshaft oilways with engine oil. Reassembling the Pankel titanium connecting rods. Fit the connecting rod to the crankshaft with the mark Pankel facing out. The cap progressive number must be on the same side as that of the connecting rod. Insert the piston pin to align the connecting rods. Lubricate thread and underhead of the connecting rod bolts with the specified grease part number 94 460 08 26. Tighten the bolts manually until they contact the connecting rod cap. Insert the 2.35 mm fork spacer number 88 713 1309 from below between the connecting rods to allow insertion of torque wrench and bush. Insert the fork thickness gauge number 88 765 1000 or 1005 or 1006, whichever is the correct size, from above to take up play. Fit the stretch gauge number 88 713 1781 to the bolts and apply the torque wrench to the bolt head. Set the gauge to 0 and tighten until obtaining 0.050 mm stretch. Repeat the procedure for the other bolt and then for the other connecting rod. Set the gauge to 0 and tighten the bolt again until achieving 0.105 plus minus 0.005 mm stretch. The torque applied to the bolt must be between 65 and 95 Newton meters, otherwise change the bolt. Repeat the procedure for the other bolt and then for the other connecting rod. Connecting rod bolts must be discarded after 3 tightening procedures. Refitting the steel connecting rods. Steel connecting rods are used in the engine with varying displacement and may look different from those shown. However, the tightening procedure shown here applies to all. The bolts used on the steel connecting rods are shorter and may not be reused after removal. The reassembly procedure for the steel connecting rods is the same as for titanium connecting rods, except for the following operations. Lubricate thread and underhead of the new connecting rod bolts with the specified grease number 82 760 08 26. Tighten the bolts manually until they contact the connecting rod cap. Insert the fork thickness gauge number 88 765 1000 or 1005 or 1006, whichever is the correct size, between the connecting rods to take up play. Tighten all bolts a first time to 20 Newton meters with the torque wrench. Tighten all bolts a second time to 35 Newton meters. Install the degree wheel to provide a reference for final tightening and set to 0. Tighten all bolts finally by rotating the wrench through 65 degrees. Shimming the crankshaft. Crankshaft bearings are angle contact ball bearings. This type of bearing withstands axial loading in one direction only. This is because radial loading generates an axial thrust in the bearing that is balanced out by the force applied in the opposite direction by the other bearing. Calculating the required amount shimming for the crankshaft is only necessary after replacing the crankshaft bearings, the engine casings and/or the crankshaft, or when the original shims cannot be reused. However, it should also be done at each engine overhaul. Fit a 1.9 mm shim number 852-1-104-1A to each end of the crankshaft. This is the smallest shim available. Shims must be installed with the rounded edge facing the shaft. Insert the crankshaft with the shims into the casing and fit each connecting rod into the cylinder seat. Install the other casing. Refit the stand bracket you have removed when separating the casings. Fit two M8 screws at opposite ends to join the casings temporarily. Do not use the drilled screw. Tighten the screws to 25 Newton meters. Place a plate on the contact face of the generator cover to support the dial gauge magnetic base. Place the gauge so that the stylus is centered with the crankshaft and set the stylus in contact with the crankshaft end. Set the dial gauge to 0 in this condition. Fit a large screwdriver between casing and crank web and lever to push the crankshaft towards the gauge. Measure play. In the engine shown here, it turned out 0.35 millimeters. To avoid excess end float when the casings expand from heat, add 0.15-0.20 millimeters to measured play to give the required preloading. The total amount of shimming required is obtained by adding the two shims installed to crankshaft, which amount to 3.8 millimeters, measured play and preloading as followed: 3.8 plus 0.35 plus 0.20 equals 4.35 millimeters. Total shimming is then divided by 2 to determine the size of each shim. Hence we will need a 2.15mm shim and a 2.20mm shim for this crankshaft. Shimming the selector drum and the gearbox shafts. Calculating the amount of shimming required for the selector drum and the gearbox shafts is necessary when the bearings, the casings and/or the shafts have been replaced or the original shims cannot be reused. However, it should be done at each engine overhaul. First, try out the shims of the size reported in the figure. Fit a 1mm shim at each end of the drum. Fit a 3.2mm shim to the clutch side end of the secondary shaft and a 1.0mm shim to the chain side end. Make sure the gearbox position switch is slackened to avoid interference with the drum. Install the secondary shaft with the gears and shims to the clutch side casing. Insert the first and fourth and second and third speed forks into the sliding gears. Preload the outer gear selector ratchet and insert the drum into the casing. Insert the fork guide pins into the drum slots. Insert the shaft into the forks and push it into the seat in the casing. Place the gearbox in neutral and make sure the selector ratchet contacts the stub tooth at the drum end. Install the chain side casing. Fit 2 M8 screws at opposite ends to join the casings temporarily. Do not use the drilled screw. Tighten the screws to 25 Newton meters. Place a plate on the contact face of the generator cover to support the dial gauge magnetic base. Place the gauge so that the stylus is parallel with the drum axis and set the stylus in contact with the drum end. Set the dial gauge to 0 in this condition. Push the drum towards the gauge and measure play. Proper operation of the selector drum is ensured when end float in the casing is within a 0.10–0.40mm range. If not so, separate the casings and change the amount of shimming to give correct end float. Fit a screw into the threaded hole of the secondary shaft. This screw will provide a fulcrum point to lever the secondary shaft. Place the gauge stylus so that it is parallel with the secondary shaft axis and set the stylus in contact with the shaft end. Push the shaft into firm contact with the casing. Set the dial gauge to 0 in this condition. Using the screw as a fulcrum, lever the secondary shaft with a large screwdriver so as to lift the shaft and measure end float. End float of the gearbox shafts in the casing must be in the 0.05–0.15mm range. If not so, separate the casings and change the amount of shimming to give correct end float. Turn the engine over on the stand so as to place the shafts in a horizontal position. Engage the first gear and check that the left fork is free. Engage the second gear and make sure that the right fork is free. Repeat the procedure with the third and fourth gear engaged and ensure that the corresponding fork is free. the fork sticks when entering the gear slot, separate the casings and change shimming to achieve smooth engagement. Use a smaller shim at the end where the fork sticks and a larger shim at the opposite end. The total amount of shimming must remain unchanged. Separate the casings and remove the fork shaft, the drum with the shims, the forks and the secondary shaft with the shims. Fit a 1.0 mm shim to the clutch side end of the primary shaft and a 1.6 mm shim to the clutch side end of the shaft. Install the primary shaft complete with gears and shims to the clutch side casing. Insert the 5th 6-speed fork into the sliding gear. Preload the gear selector ratchet and insert the drum into the casing. Insert the fork guide pin into the drum slot. Insert the pin into the fork and push it into the seat in the casing. Place the gearbox in neutral and install the chain side casing. Join the casings temporarily as described for the other shafts. Turn the engine over with the clutch side up and install the nut to the primary shaft temporarily. Tap the nut to push the shaft into firm contact in the casing. Place the gauge so that the stylus is centered with the shaft and set the stylus in contact with the shaft end. Set the dial gauge to 0 in this condition. Using a supporting surface and the nut, lever to lift the primary shaft and measure end float to make sure it is within the specified limit. Turn the engine over on the stand to set the shafts in a horizontal position. Check that the sliding gear is centered with the gearbox in neutral. Engage the 5th gear and check that the fork is free. Repeat the procedure with the 6th gear engaged. If the fork sticks, change shimming but keep the total amount of shimming unchanged. Separate the casings and refit all the shafts with the correct shims. Join the casings. Gear selector adjustment. The position of the gear selector relative to the rollers of the selector drum is critical to proper gearbox operation. Refit the gear stopper inserting the ball, the spring, the seal and the screw into the seat in the clutch side casing. Tighten the screw to 30 Newton meters. Before refitting, check that the gear selector lever is midway between the end plates. Slacken the check nut on the gear change lever eccentric. Rotate the eccentric so as to center the lever between the end plates. Tighten the check nut. Install the complete gear selector lever to the engine. Secure it to the casing with the M8 screw and position the pull to the drum rollers. Engage the second gear using a service lever. Fit the locating plate number 88 713 1091 to the drum rollers. Make sure the center line mark on the pawl is lined up with the edge of the plate. If not so, slacken the screw and shift the selector lever until obtaining the correct alignment. Tighten the screw to 25 Newton meters. Fit the other retaining screw and tighten to 10 Newton meters. Reassemble the engine by reversing the disassembly procedure. Observe the assembly instructions highlighted by the special symbol. Please refer to the relevant workshop manuals for the specified thread lockers and torque wrench settings. The correct assembly and tensioning procedure for the timing belts is illustrated in the video cassette, Valve Clearance Inspection and Adjustment with Timing Belt Tension Adjustment.